All right, so my name is Emily Rouse. I'm a previous orthoptist at the University of Michigan, and I taught the optics chapter. And I was just going to record myself going through the problem on page 13, number 3. So this problem is a little bit intimidating to students studying optics because it is so long and in depth. So this is going to be a full run through of this problem. It is an 8 lens system with the first lens being +8, second lens +8, third lens is -6, and then fourth lens +2, +3, -1, -4, +7. And then the problem also lays out the distances between every single lens given explicitly to you. So this is going to be a very repetitive process, with the biggest part of the problem being drawing where you're at back in the big picture above. So we're going to start with diopters equals 1/distance, and our object is located 20 centimeters in front of the first lens. So my O1 is going to be 20 centimeters from the first lens. So first thing that we're gonna do is, going to be, get on the right page of my notes here. We're gonna convert the 20 centimeters into meters. So that would be 1/5 of a meter. We're going to use diopters equals 1/distance. D equals 1/d. Diopters equals 1/1/5. And then when we find the reciprocal of this, and it just simplifies down to 5. And is our 5 positive or negative? It is going to be negative because our object is in front of our lens. Then we're going to plug this into U plus D equals V equation. So in this equation, D is going to be D1, U1, V1. Diopter of the first lens is going to be +8. The U is going to be our object. We said our object was 20 centimeters, and that was this number that we just found out here. So that's -5 plus 8 is going to be equal to V1. When we do the math, this comes out to 3, and it's going to be positive. If we then plug this back into diopters equals 1/distance, we get 3 equals 1/d. Little d equals 1/3. And it is positive, so that means it is going to be behind. So if we come up into our picture here, 1/3 of a meter behind the first lens. The distance between the first and second lens, the whole thing is 2/3 of a meter. So it is probably going to be in the middle there. This is going to be I1, which is also O2, object 2. So we're going to do this whole process again here. So we're going to divide our working space. We're going to start now from our object 2 and finding how far away this is to lens 2. We know that the distance from here to here was 1/3. Now we're trying to find the distance from here to here. The whole thing is 2/3. From the lens to where our object is was 1/3. So the remainder of this is going to be 1/3. So 1/3 of a meter. It is in front of this +8 lens, so it's still going to be negative. This is 1/3 of a meter. We still need to plug this into diopters equals 1/distance. Diopters diopters equals 1 over 1/3. Diopters is then going to simplify to a 3. We discussed that it's in front of this second lens, so that is going to make it negative. We're then going to plug this into U plus D equals V. Our U is going to be what we just figured out, the -3. This is going to be subscript 2. Our D2 is our lens 2, so our lens 2 is still a +8 for this. And it is going to be -3 plus a +8 is going to be equal to V2. That comes out to a +5 equals V2. We need to then plug this back into diopters equals 1 over distance. Our +5 equals 1 over little d. When we simplify this, it becomes little d equals 1/5 of a meter. It is positive, so that is signifying that it is behind lens 2, or about 20 centimeters. So my picture is not quite drawn to scale, but in 20 centimeters behind lens 2 is going to bring me into this territory, because the whole distance between this +8 to the -6 lens is only 10 centimeters, but the whole thing from the -6 to this +2 is 50 centimeters, 1/2 of a meter. So I'm probably going to be somewhere about here-ish. This is going to be my image 2, also my object 3. So we're going to squiggle here. How far away is object 3 from the third lens? We know that the whole thing from lens 2 all the way over to object 3 was 20 centimeters. This smaller portion was 10, so the remainder of what was left is also 10 centimeters. It's going to be 10 centimeters behind this lens number 3, so that is going to make it positive. So we still need to plug this into, which is going to be a tenth of a meter when we plug it into meters. Diopters equals 1 over distance. Diopters equals 1 over 1/10. When we simplify this, it becomes 10. It's going to be positive because it's behind. We're going to plug this into U plus D equals V. This is subscript 3 because we're going through lens 3. The U we just figured out was a +10 plus the power of lens 3, which is -6, equals V3. When we solve this, we come out to a +4 equals V3. If we then go through diopters equals 1 over distance, we are then going to come up with 1/4 of a meter. It is still going to be positive, so that means we are behind lens 3. So we come back up to our big picture here. 1/4 of a meter is going to be 25 centimeters. We know the whole thing from the lens 3 all the way over to the lens 4 is 50 centimeters. So if we're only going 25 centimeters, that's going to be this halfway point. This is now going to be our I304. Trying to figure out the distance now from 04 to lens 4. We can do our little squiggle here. And we're going to have to do diopters equals 1 over distance again. So we know that the whole thing was 50. We're 25 centimeters away from here, which means the residual from this middle point over to the +2 lens is still going to be 25 centimeters. 25 centimeters is also 1/4 of a meter. Diopters equals 1 over distance. We are in front of this +2 lens, so it's going to be negative when we come out to this. Diopters equals 1 over 1/4. Diopters equals 4. we're gonna make it negative because we are in front of this lens. We're gonna plug it into U plus D equals V. This is gonna be going through lens 4. So we're gonna have subscript 4 up here. We just figured out U minus 4 plus, we're going through the fourth lens, 1, 2, 3, 4 is gonna be 2 equals V4. Negative 4 plus 2 is going to be negative 2 equals V4. If we plug this back into diopters equals 1 over distance, we are going to be getting distance equals 1/2, negative 1/2, because we're going to carry our negative through there. Negative meaning in front. So we are 50 centimeters in front of this +2 lens, which actually brings us to exactly where this -6 lens here is. So this is going to be I405. If we do swiggle, 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 we're going to go through and do the 05 going through lens 5. I4, object 5. Object is 50 centimeters in front of lens 4, which is 50 centimeters in front of lens 5. So if we add, how far away is this all the way over to the +3 lens? So it is going to be 50 centimeters plus 50 centimeters. This is going to be 100 centimeters or 1 meter. Makes our math a little simple over here. So 1 meter is going to be this distance from here all the way over to there. If we go through, we're going to have diopters equals 1 over distance. Big diopters 1 over 1. It just is going to be equal to 1. It's in front of the +3 lens, so it's going to be negative. We plug this into U plus D equals V. This is going to be going through lens 5. We just figured out that U5 is -1 plus lens 5, which is +3, equals V5. This is going to be equal to +2 equals V5. Then we have to go back into diopters equals 1 over distance. 2 equals 1 over D. Little d equals 1/2. It is going to be positive, so it's going to be behind. So 1/2 behind this lens. The whole distance from, which is 50 centimeters, the whole distance from this +3 over to this -1 is 3/4 of a meter, or 75 centimeters. So we're going to be somewhere over here. And this is going to be our I5, which is also 06. We said the whole distance from +3 lens to the -1 lens is 75 centimeters. We just figured out that this distance to this distance is 50 centimeters. That means that the distance from I5 over to the -1 lens is going to be the residual 25 centimeters. We're going to do some erasing on the board so we have a little more room to keep going with our math, but I'm going to keep our big picture up at the top. So we said I506 is 25 centimeters, which is going to be 1/4 of a meter. we have to go diopters equals 1 over distance. The diopters is going to be 1 over 1/4. That simplifies down to 4. It's going to be negative because it's in front. U plus D equals V. We're going through lens 6. We just figured out U was -4 plus, we're going through the 6th lens, which is the -1, equals V6. -4 plus -1 is going to be -5 equals V6. Diopters equals 1 over distance. -5 equals 1 over little d. If we solve this, d equals 1/5 negative of a meter. Negative meaning it is in front. In front. So if we go back up to our picture, 20 centimeters, 1/5 of a meter in front of our 6th lens. We said the distance from here to here is 25 centimeters, so just slightly closer is going to be our I607 in our picture. So distance from here to here is 20 centimeters, and the whole distance from the -1 all the way over to the -4 lens is 30. This 20 plus the 30 is going to be 50 centimeters. If we then go through and do U plus D, or D diopters equals 1 over distance, for this, we have 50 centimeters. Diopters equals 1 over distance. 50 centimeters is also equal to 1/2 of a meter. Diopters equals 1 over 1/2. That simplifies down to 2, and it is well in front, so it is going to be a -2. We plug this into U plus D equals V. We're going through lens 7, so subscript 7. -2 we just figured out is U7 plus the 7th lens is going to be -4 equals V7. -2 plus -4 is equal to -6. V7. We gotta make this back into a distance. Diopters equals 1 over distance. -6 equals 1 over little d. Little d equals -1/6 of a meter. So negative means it's in front. We have 1/6 of a meter in front is going to be somewhere in the middle up here. It's not quite 1/3 of a meter. 33 centimeters is 1/3 of a meter. So 1/6 of a meter is going to be probably somewhere in about the halfway mark here. And it's 1/6 of a meter, negative, so it's in front. This is going to be our I708. Distance from I7 to the 7th lens of the 1/6 of a meter. The distance from the -4 lens all the way over to the +7 is also 1/6 of a meter. 1/6 plus 1/6 is going to be 2/6, which then simplifies down to 1/3. If we plug this into U plus D equal, or diopters equals 1 over distance again, diopters equals 1 over 1/3. this is going to simplify down to a 3. That's well in front, so that makes it negative. U plus D equals V. We're going through the 8th lens. Our U we just figured out was negative 3. The dioptric power of the last lens is a positive 7 equals V8. This simplifies down to a positive 4 equals V8. Diopters equals 1 over distance. 4 equals 1 over little d. Little d equals 1/4 of a meter. It is positive, so that means we're behind. So our final answer is going to be that the image 8 is going to be 1/4 of a meter behind the 8th lens. So if we were to add that up to our picture over here, it would be somewhere over here is going to be our eye